let's go through the features of a sine function. So any sine function can be written as y is equal to a times sine of b times x minus c in parentheses and plus d. Now I'll go to what all of these variables mean. So let's go through d first. What does this d mean in this formula? Well, take a look at the graph of sine of x, right? This is the graph of sine of x. Now, d represents something known as the midline. So the midline, as you might tell from the name, it's the line that's in the middle of this graph. So it's going to be this line right over here. In a sine function, the highest y value for sine of x is positive 1, right? The highest y value for sine of x is positive 1. And the lowest value for sine of x is negative 1. So that means that the line that goes in between 1 and negative 1 has to be 0, right? Which represents the midline. That's why in this equation, y is equal to sine of x, you can actually rewrite this as y is equal to sine of x plus 0. And this 0, or this d term in the outside, the term on the outside highlights your midline, which in this case is equal to 0, right? Because the line is in between 1 and negative 1, which are the highest and lowest points. So the highest points on the graph, so you'll notice this point right over here, this point right over here, they are something known as the crest. So the crest represents the highest points on the graph. And the lowest point on the graph, the point with the lowest y values, so these points right over here, they represent something known as the trough. They are the lowest points on the graph. All right, so we have midline covered. Now we have C, which stands for horizontal shift. So right now we're dealing with the equation y is equal to sine of x. But what happens if I put y is equal to sine of x minus 3? What will this graph look like? Well, one way to kind of think about this is, let's go back to, algebra class. Let's say we have y is equal to x squared. Now, when you put an x minus 3 here, what happens to the graph? It shifts 3 units to the right. And if you add 3, well, it shifts 3 units to the left. So when you subtract a number, it moves the graph that number to the right. And if you add a number, it moves that number to the left, right? So this is, what you might have learned from algebra class with polynomials, right? How to shift polynomials. With sine functions, it's the same thing. So if you have sine of x, right? If you put I'll just put this up for comparison. If you put a minus 3 here, well, look what happens. You've basically moved the original function 3 units to the left, right? Look, so let's say if I'm comparing this point, right? Well, guess what? The next point for other graph is shifted 3 units to the left. And if I put, so let's say sine of x minus 4, minus 5, minus 6, minus 7, minus 8, right? You notice how as I put kind of a certain number in, it moves the sine graph, that number to the right. If I were to add a certain number, let's say plus 1, plus 2, plus 3, plus 4, you notice how now this time it moves to the left that many units, right? Originally, our point is 0, 0, right? This is, let's say, our comparison point. Well, now our comparison point has shifted, 4 units to the left, which is coming from this plus 4. So that is what horizontal shift is. It is this kind of thing in the middle that you can subtract or add, and it moves the function left to right. Period. What is the period of a graph? Now, what the period is, in this case, let me just tell you that the period for a sine function is 2 pi. The period for a sine function for y is equal to sine of x, it's equal to 2 pi. All right, it's equal to 2 pi. Period is basically how long does it take for the function to go up and down and back up to that original point, right? Our original point is 0, 0, right? And notice how it's moving upwards, right? It's moving upwards. Well, how long does it take for the graph to come back to the same point? Well, guess what? It takes 2 pi, right? Once we go another 2 pi right over here, once we go another 2 pi to the right, well, look what happens. We're back at the same point, right? The y value is still 0, right? So we've gone back to the same y value, and guess what? It's also moving upwards. So that is a period of the graph. You might be wondering, why isn't this point pi comma 0? Why isn't this point a period on the graph? Even though these 2 points have the same y value, this point right over here is going downwards. It's not going the same direction as the 0, 0 point. Summarize everything. A period is kind of how long does it take for the function to go back to kind of the same y value at the same direction. So this b term right over here represents the period of the function. And you can actually find out the period of a function using this formula. 2 pi divided by the absolute value of b. For example, let's say if I have the equation y is equal to sine of 2x. How will you find out the period of this graph? Well, all you have to do is you have to take the b value, right? We said how the b value is sort of the next thing that's inside the sine, right? It's right next to the sine symbol. So this 2 right over here is right next to the sine symbol. We take that number and we divide 2 pi by it, by the absolute value of 2. So we take 2 pi divided by the absolute value of that number. The absolute value of 2 is just 2. So it's just going to be pi. And there we go. That is the period of this graph. So let's say if we were looking at sine of x, right? We go up, then we go down, and then we go up again, and that's 2 pi, right? And look at the other graph, right? Look at the other graph, the purple graph. We go up, then we go down, then we go up again, then we go down again, and then we reach there. So notice how this purple graph, this transformed graph, is 2 times, you can think about it as 2 times faster, right? 2 times oscillating faster than the original sine graph. The sine of 2x, it goes up and down 2 times faster than the sine of x. If we have sine of 3x, then look at this. It goes up and down 3 times faster than sine of x. If we have sine of 4x, sine of 5x, notice how as I plug in bigger and bigger numbers, well, it's just going to oscillate up and down more and more. And you might be wondering, well, what happens if I place a negative sign in here, right? So let's say if I have sine of x, right? What happens if I put a sine of negative 1x? Well, the function is just going to be flipped around by the y-axis. So if this is the y-axis and this is our original graph, the blue graph, well, it's just going to be flipped around across this y-axis, and boom, there you go. So pi comma 1 becomes pi comma negative 1. So the y value has now become negative. All positive values become negative, and all negative values become positive, right? So if we take a look at the blue graph, which is our original graph, this negative 1 became positive 1. And then for this blue graph, this 1 now became negative 1. So you just flipped it around the y-axis. Finally, I want to talk about amplitude. Amplitude, you can think about it as, okay, you can pick either a top point or the bottom point. So let's say we pick a top point. It's the distance from this top point to the midline. That is the amplitude. It's just the distance from the highest point to the midline, or the lowest point to the midline. Both of them should have equal distances. So in this case, for a regular sine graph, the amplitude is actually 1. And that kind of makes sense, right? We know that the midline is y is equal to 0, right? Y is equal to 0. So it's this line right over here. We know that the maximum point is 1 and negative 1. The minimum point is negative 1. So the distance from these points is going to be 1, right? The distance from the highest all the way down is going to be 1. So if you take a look here, if we have y is equal to sine of x, let's say I put a 2 sine of x, well, guess what? It's going to be 2 times as high as before, right? The distance between the highest point and the midline is now 2 times as high. Because keep in mind, this number in the front only changes the amplitude, right? We haven't changed the midline, right? The midline is this plus d at the end, right? But we haven't changed the value of this d, which means that only the amplitude is being affected. So now we are going 2 times as high. If we put a 3 here, well, now we're going to 3 times as high, right? Every value for sine of x has now been multiplied by 3, which means that this highest value has to be multiplied by 3, right? It's sort of like saying if x is equal to 3, then 3x is going to be equal to 9. It's sort of like the same thing, right? If we're multiplying this thing by 3, well, the highest point is going to be multiplied by 3, so this 1 is going to become 3, right? So if you put a 4 there, put a 5 there, well, it's just going to get higher. Kind of the highest point is going to get higher by a factor of 5. That's basically what it means. If you put a negative sign here, it also flips it around the y-axis, which means that sine is actually an odd function. So sine is an odd function because f of negative x is equal to negative f of x. Now, if y'all don't know even and odd functions, please check out this video. Alright, so that's something cool about sine of x. It's an odd function. So if I place, for my amplitude, right, if I place a negative sign out here, all it does is it reflects our original function. It reflects our original function across the y-axis. So now if I put a -1, -2, -3, now it's basically like it expanded, but it's in the opposite direction. So look at 3 sine of x, and now look at -3 sine of x. You just flip it across the y-axis, and then you're done. Let's say we wanted to graph the function y is equal to 3 times sine of x minus 3 plus 4. So how would we do this? Well, first of all, we got to know what the function y is equal to sine of x is equal to. If we don't know what the original function looks like, how can we know what, the transform function looks like? So, if you want to solve these problems, you have to memorize the sine function, and once we start doing the other questions, you got to memorize the sine and cosine functions. So that's something that's really important. Now, even if you don't memorize it, you can use the unit circle to help you do this. So when you have a 0-degree angle, your y value is 0, right? So when you have gone 0 radians across the unit circle, your y value is 0, or your sine value is equal to 0, okay? So when you create a 0-degree angle, your sine value is equal to 0. When you create a 90-degree angle, so when you create something like this, you create a 90-degree angle, well, the coordinate of this point right over here is 0, 1. And we know that sine represents the y value of that coordinate. So sine of 90 degrees is equal to 1, or sine of pi over 2, because 90 degrees is the same thing as pi over 2. So also make sure to, know how to convert from degrees to radians, all right? You got to be comfortable with using this type of kind of degree notation. Now, when you go pi radians across the unit circle, so 180 degrees, well, your y value is back at 0. So when the angle is pi radians, well, your y value is 0. When your angle is 270 degrees, so it looks something like this, well, guess what? Your y value is now -1. So right over here, and then it has to go back up. And you kind of see the pattern, right? Even if I don't know what the rest of the graph looks like, just by looking at these couple of points, well, I can be like, okay, so I know the next point at negative pi over 2 has to go to the bottom, right? Because it just went to the top. The point just went to the top, and now it's going down, right? Then once it reaches the bottom, then it has to go back up, right? So it's going to go to the middle, then it's going to go back up. So just from knowing a couple of points in your sine function, well, you can actually graph out the rest of the function, right? Because it follows a predictable pattern, right? You just down, down, up, down, up, and just continues on forever. As long as you know your kind of distance between the units, right? So kind of your intervals, as long as you know these, and the intervals are going to be constant. So you notice how every jump is pi over 2, right? So as long as you know your intervals, well, you're going to be set to solve this problem. Now, enough yapping, and let's get started. So let's say that I have y is equal to sine of x plus 4. How would this look like? So if I have y is equal to sine of x plus 4, how would this function look like? Well, this 4 at the end just moves everything up by 4. And you can kind of think about this intuitively, right? If you have the function y is equal to sine of x, well, if you add 1 to the function, well, every value that it originally was, well, this plus 1 right over here is going to make it go up by 1, right? You're just going to add 1 to whatever values that are originally there. Meaning that if I have plus 4, I'm just going to move it 4 units up. So let's ask ourselves, what does the function y is equal to sine of x minus 3 plus 4 looks like? So all we did was we added this minus 3. How would this function look like? Well, it would literally be the same function as this, y is equal to sine of x plus 4, except this minus 3 makes it so that everything moves to the right by 3 units, right? So in this case, I'm just going to move every point to the right by 3 units. So this is kind of like the strategy for doing this problem. You do it transformation by transformation. So first, I did the midline transformation first, then I did the horizontal shift transformation second. Finally, I'm going to do the amplitude transformation. And then we're done with the problem. All right, so whenever you're doing these problems, always make sure that you're doing these problems like step by step, because it can be really confusing to approach this problem like all of these transformations at once, you know. So you kind of have to do it step by step. So now I'm just going to move every point to the right by 3. So I'm kind of going to eyeball it. So here we go. So all we did was we took the green graph, which we knew was y is equal to sine of x plus 4, and we just moved everything to the right by 3 units, because that's what this minus 3 does. Just moves everything to the right by 3 units. So the red graph represents everything moved, right? This moved by 3, this one, every point moved by 3 units. All right, just added a couple of points. So basically, what this 3 is telling us is basically, well, instead of our amplitude being 1, as it originally was, now the amplitude has to be 3. So the graph is going to look something like this. And then it's going to go all the way down to 1. And it's going to go back to the middle. Then it's going to go all the way back to 7. And then the cycle repeats. All right, so this dark red looking graph is the graph of y is equal to 3 times sine of x minus 3 plus 4. All we did to this graph is, look, we said that this graph right over here, y is equal to sine of x minus 3 plus 4. Well, this right over here had an amplitude of 1, meaning that the distance from the highest point to the midline is 1, right? That is what this 1 represents. Well, all we did to change this, to turn this graph into this graph, is, well, we changed the distance between the midline and the highest point to be 3 now. So this distance right over here has now been changed to 3. With just a quick review of how we did this problem. So we know what the graph of y is equal to sine of x looks like. You can use the unit circle to help you with this. And now, in order to find the graph of y is equal to 3 times sine of x minus 3 plus 4, how do we find out what this graph would look like? Well, we take a look at our original graph, and we slowly start adding layers to this. So first, we add this plus 4. We know what this does. This moves the function up by 4 units, right? Then what we do is we can plug in the minus 3. So we slowly start adding in our transformations one at a time. This minus 3, well, look what it did. It moved everything to the right by 3 units. Finally, we add on the 3 at the front, and basically what this does is it kind of stretched it by a factor of 3 in the y direction. So basically the distance now from the highest point, which we know is 7, to the midline, which is at 4, 7 minus 4 gives us 3, which represents this 3 in the amplitude.